Imagine this scenario. You're putting the final press on a crisp white shirt for a massive job interview or, some major event.
Oh, no, I think I know where this is going, right.
Right. So you've got the ironing board set up. The lighting is perfect. You press the hot metal down onto the collar, hit the steam button, and instead of a clean, invisible mist, the machine violently spits this dark, rusty, chalky sludge right across the fabric.
Just completely ruins the shirt.
Your shirt is ruined, your timeline is blown, and the tool you trusted to make you look pristine has completely sabotaged you.
It's a devastating moment. And honestly, it happens far more often than we like to admit.
Yeah.
There is this fundamental blind spot in how we maintain our homes. Like, we buy appliances designed to clean or perfect our belongings, right?
Yeah.
Washing machines, dishwashers, clothes irons.
And we just assume they are self-maintaining.
Exactly. We view them entirely as the solution, and we rarely recognize that anything interacting constantly with heat and water is, well, it's fundamentally destined to become a problem.
Which brings us to the core of today's deep dive.
Yeah.
We're looking at a seemingly mundane, everyday object that carries incredibly high stakes for your wardrobe: the clothes iron.
A highly underrated tool.
Truly.
Yeah.
So, to ensure you never have to experience that ruined white shirt scenario, we are pulling directly from a highly specific step-by-step maintenance guide provided by the Home Depot.
Right.
Our mission today is to extract the underlying mechanics of this guide. We want to understand the why behind the methods so you can keep this vital tool in absolute, like-new condition.
And what stands out immediately when reviewing the source material is the sheer level of rigor involved. I mean, the Home Depot guide doesn't just tell you to wipe the appliance down with a wet rag.
No, it's intense.
It really is. It outlines the strict sequence involving specific chemical ratios, thermodynamics, and strict safety protocols. It approaches the iron not just as a hot piece of metal, but as a complex plumbing system that requires deliberate, basically scientific maintenance.
So let's get right into that sequence. The guide draws a very hard line right at the beginning. Before you even attempt to start this process, the iron must be unplugged and completely cool.
Yes, baseline safety first.
Always. And once you've established that baseline safety, it points your attention to a place most of us honestly never look, which is the inside.
Which is the most logical place to begin, really. You cannot effectively clean the external contact surface of a machine if its internal plumbing is just constantly feeding it contamination.
Right. That makes sense.
So the guide focuses first on the reservoir, the hidden internal chamber that holds the water, feeds the heating element, and generates the steam.
Right, the internal plumbing. And to clear that out, the guide prescribes a very specific mixture for an internal flush. It's 1/4 cup of white vinegar combined with 3/4 of a cup of distilled water.
Very precise.
Yeah, you pour that exact mixture into the reservoir, plug the iron in, and let it heat up.
But what I find interesting here isn't just the ingredients, but the ratio. Like, why such a specific blend? It comes down to the chemistry of what we're trying to remove. If we think about the geology of an iron, every time you put tap water into that reservoir and heat it up, the water eventually turns to steam and leaves the iron.
Right.
But the microscopic minerals suspended in that water, so we're talking calcium, magnesium, they do not evaporate. They are left behind.
Oh, wow.
Yeah. So over time, those minerals build up inside the dark, damp chambers of the iron.
It's essentially the same process that forms stalactites in a limestone cave, isn't it?
That is a perfect analogy, yeah.
You just have water slowly depositing rock inside your appliance over hundreds of uses. It's like a respiratory detox for the appliance.
Exactly. You are dealing with hardened physical rock deposits, so a basic soap won't do anything. You need an acidic environment to break down those alkaline mineral deposits.
Enter the vinegar.
Right. The acetic acid in the white vinegar is ideal for this,
Yeah.
but pure vinegar would be too caustic. It could actually damage the internal seals of the appliance.
So you have to dilute it.
Yes. By diluting it precisely with 3 parts distilled water, the text ensures you create a solution that is acidic enough to dissolve the stalactites, but gentle enough to protect the machine itself.
And using distilled water for the dilution is key there too, because you don't want to introduce new minerals while you're trying to dissolve the old ones, right?
Exactly. That would defeat the whole purpose.
So you have this acidic mixture heated up inside the reservoir. The guide then instructs you to press the steam button and hold it until steam emerges. And you have to repeat this precisely 3 to 6 times.
Right. So the steam in this scenario is acting as your transport mechanism. The heat accelerates the chemical reaction between the vinegar and the mineral scale, breaking those solid deposits down into a slurry.
Right.
But that slurry is still trapped inside the iron. By forcefully engaging the steam function repeatedly, you're using pressurized gas to physically blast that dissolved sediment through the internal labyrinth of vents and out of the machine.
I see. The source actually mentions using cotton swabs on the steam pads to remove mineral deposits or sediment. So the vinegar and water are actually breaking down physical rocks and dirt inside the iron and pushing it out.
Precisely. The acid dissolved the rock, the steam transported it out, and now it's sitting on the surface waiting to be manually swept away by the cotton swabs. It's a complete evacuation of the internal plumbing.
That's incredibly thorough.
It is. But it's crucial to note how the guide closes this first phase. Once you've swabbed the vents, you must unplug the iron and wait for it to cool down entirely before you empty out whatever vinegar mixture is left in the reservoir.
That feels like a very strict adherence to safety.
Oh, absolutely.
Because, I mean, you are essentially handling a handheld boiler full of near-boiling acidic liquid. Letting it cool before you turn it upside down over a sink is just basic self-preservation.
It is, and it also dictates the timing of the entire operation. This isn't a quick 5-minute chore. The deliberate heating and cooling phases mean this is a maintenance protocol that requires some patience.
Which brings us directly to the second phase. The internal reservoir is flushed, cooled, and emptied. The guide now shifts our focus to the outside of the machine. The Soleplate.
Right, the flat metal surface that actually touches your clothes.
Yeah, and for this, the text provides a totally different recipe. It's a paste made of 1 tablespoon of water mixed with 2 tablespoons of baking soda.
Notice the shift in the chemistry here. For the internal plumbing, we used an acidic liquid to dissolve minerals. For the external Soleplate, we are using an alkaline paste.
That tracks because the type of dirt on the outside is completely different, right? Like the inside is dealing with water, minerals, but the outside is dealing with the friction of ironing.
Exactly.
It's picking up burnt starches, stray synthetic fibers from cheap fabrics, and just, general environmental grime. It needs an exfoliating scrub for metal, basically, not a chemical soak.
And baking soda is brilliant for this application. It provides enough physical abrasion to scrub away scorched organics and synthetics, but it is softer than the metal or ceramic of the Soleplate.
So it won't scratch it.
Right, it won't leave microscopic scratches.
Okay, so you apply this paste, scrub the Soleplate, and wipe it clean with a damp cloth. But I have to push back on the sequence of operations here.
Oh, how so?
The guide is incredibly firm that this baking soda paste must be applied while the iron is unplugged and completely cool.
Yes.
But we just had the iron screaming hot to clean the inside. Then we unplugged it and let it cool. And now we're applying a paste. Why not just do the inside and outside at the same time while the metal is hot and the grime is loose?
It is a tempting shortcut, for sure, but it would be disastrous in practice.
Really disastrous.
Oh, yeah.
Yeah.
If you apply a paste consisting mostly of baking soda and a little bit of water to a hot Soleplate, the heat of the metal will cause the water in the paste to instantly flash boil and evaporate.
Oh, I see. You wouldn't be wiping the paste around. You'd just be instantly drying it out.
Worse than that, you would literally bake the baking soda directly onto the Soleplate.
Oh, wow.
Yeah, instead of removing a layer of grime, you would be cooking a hard, crusty, alkaline shell onto the exact surface you were trying to clean. So the strict separation of phases, the hot acidic flush for the inside, followed by the cool alkaline scrub for the outside, it's a deliberate chemical necessity.
Okay, that makes perfect sense. But looking at the mechanics of this, if I just smeared a thick baking soda paste all over the bottom of my iron, I feel like I've got a massive new problem.
Which is?
The Soleplate is covered in dozens of tiny little vent holes for the steam. There is no physical way to wipe that plate clean with a damp cloth without shoving a significant amount of that white paste up into the vents. I've essentially spackled my iron's plumbing closed.
That is a highly accurate deduction. And if you stop the process there, the next time you tried to iron a dark garment, the machine would spit hot, white baking soda chunks all over it.
Which brings us right back to the ruined shirt from the beginning.
Exactly. But the Home Depot text anticipates this exact mechanical consequence, which is why it introduces a dedicated purging phase.
Right, you have to clear the vents. You have to clear the spackle.
Yes.
So to do this, the guide instructs you to turn the iron back on, fill it entirely with pure distilled water, so no vinegar this time, select the steam setting, and run the iron forcefully over a thick towel while holding down the steam button.
It is a purely physical purge. We aren't trying to dissolve anything chemically anymore. We are using the brute force of pressurized steam to blast those vent holes clear from the inside out.
Hence the pure distilled water.
Right. Using pure distilled water ensures you are flushing the system clean without introducing any new mineral deposits back into the internal chamber you just spent all that time descaling.
And the instruction to use a thick towel specifically is crucial. You aren't just hovering the iron in the air, you are pressing it into the towel.
Exactly.
It's like the iron is coughing out the remaining paste. You're ejecting a high-velocity slurry of hot water, leftover baking soda, and residual grime directly into the fabric.
Yeah, and a thin t-shirt isn't going to safely capture that kind of particulate matter or heat. The thick towel acts as an absorbent landing pad. It's a quarantine zone for all the debris, completely isolating it from your actual wardrobe.
So your clothes are spared from a messy ironing mishap.
It is the ultimate preventative measure. You give the appliance a safe environment to violently expel all the loosened contaminants. Once it runs clean on the towel, you know it is safe for your clothes.
For standard routine maintenance that sequence the internal flush, the cool scrub, and the towel purge, it sounds incredibly comprehensive.
It is.
But what I find fascinating is that the guide acknowledges a reality we all face. Sometimes you mess up badly enough that standard maintenance simply won't cut it.
Right. The guide pivots here to a section addressing what it calls stubborn residue.
The worst kind of residue.
Truly. This implies a situation where something has structurally bonded to the sole plate. Usually it's a synthetic fabric blend that couldn't handle the heat setting and physically melted onto the metal, creating this fused, plasticized layer.
The dreaded black smear on the bottom of the iron.
Yeah, that's the one.
So the method the text prescribes to defeat this is, honestly, it's an escalation in tactics that I wasn't expecting from a basic household guide. Let me unpack this.
Oh, for it.
First, you turn the iron on and heat it up until the stubborn residue becomes somewhat pliable.
Okay.
Then, you unplug the iron and you place the hot sole plate directly onto ice for about 10 minutes. Finally, you take a dull plastic edge, gently scrape away the hardened residue, and wipe the plate clean.
It is a remarkable sequence that relies heavily on thermodynamics and material science.
Wait, let me just pause here because I have a healthy dose of skepticism.
Sure, lay it on me.
We are talking about taking a purposely heated, hot electrical appliance and literally plunging the metal plate directly onto a block of ice. Doesn't extreme thermal shock risk physically cracking the sole plate or damaging the internal electronics? I mean, I've seen hot glass shatter instantly when it touches cold water.
It is a valid concern, and it highlights the engineering of the appliance itself. Unlike a glass baking dish, an iron sole plate is cast from materials specifically designed for rapid thermal cycling.
Okay, so they're built for it.
Yes, they're usually thick stainless steel, aluminum alloys, or reinforced ceramics. They are engineered to heat up quickly and dissipate heat efficiently. So placing it on ice induces a rapid temperature drop, but the structural integrity of the sole plate is robust enough to handle the contraction.
Interesting.
The true target of the thermal shock isn't the metal, it's the residue.
So let's break down that physical reaction because the text is using heat and cold as tools. Step one is heating the iron to make the residue pliable. We are essentially taking that fused, melted plastic and softening it, breaking its rigid state.
Correct. At room temperature, that melted synthetic polymer is locked tightly into the microscopic pores of the metal. By introducing heat, you increase the kinetic energy of the molecules in the residue, causing it to soften and become sticky.
But if it's soft and sticky, you can't just wipe it away with a rag.
Yeah.
You'd just be smearing hot tar across an even larger surface area of the metal.
Precisely. You would make the problem worse. And you'd risk burning your hands trying to scrub a near-boiling surface.
Good point.
This is where the brilliance of the rapid phase change comes in. By unplugging the iron, removing the heat source, and immediately pressing that pliable residue onto ice, you force an instant, drastic drop in temperature.
Extreme thermal contraction.
Yes. The metal of the sole plate and the synthetic polymer of the residue react to that extreme cold at vastly different rates. The soft, sticky gunk instantly freezes, turning into a hard, brittle shell.
Oh, wow.
And as it rapidly contracts, it violently breaks its own adhesive bond with the metal. You are literally using physics to shear the connection between the dirt and the appliance.
That is incredible. So the thermal shock does the heavy lifting of breaking the bond, which leads directly to the final, highly specific tool the guide recommends: a dull plastic edge.
Right. And consider the material science of that choice. Why not use a kitchen knife or a metal spatula to scrape off the brittle shell?
Because metal scratches metal.
Mm,
If you take a hardened steel blade to a Soleplate, you are going to gouge the finish.
exactly.
And once you leave a permanent scratch on that surface, every time you iron, that scratch is going to catch delicate fibers, pull threads, and slowly destroy your garments. You'd fix the immediate residue problem, but permanently ruin the appliance.
Exactly right. The text specifies a dull plastic edge because plastic occupies the perfect middle ground on the hardness scale for this specific task.
It's hard enough, but not too hard.
Right. It is harder than the frozen brittle residue, meaning it has the structural integrity to snap the gunk off the plate. However, it is significantly softer than the stainless steel or ceramic of the sole plate, guaranteeing that it cannot leave a scratch no matter how hard you scrape.
It's basically an incredibly precise, engineered solution, masquerading as a simple household tip.
It is a masterclass in using temperature extremes to your advantage and utilizing the physical properties of the materials around you. You soften the enemy with heat, freeze it into a brittle state with ice to break the structural bond, and safely snap it away with a perfectly calibrated plastic tool.
It proves that effective maintenance isn't just about applying mindless elbow grease. It is about understanding the environment you're trying to alter.
Absolutely.
The acidity of the internal flush, the alkalinity of the external scrub, the forceful physics of the towel purge, and the rapid thermodynamics of the ice bath. Every single element is carefully sequenced to solve a specific mechanical problem.
It really is beautifully logical when you break it all down.
It is. So let's step back and recap the whole journey for you, the listener. If you want to ensure your iron is always the solution and never the problem, it requires a systematic approach. You start inside, utilizing the precise chemical reaction of white vinegar and distilled water to dissolve hard mineral scale, using steam to forcefully evacuate the plumbing.
Right. You then move outside, recognizing that the external sole plate requires an alkaline baking soda paste applied strictly when the metal is cool to avoid baking a crust onto the surface.
Then you anticipate the consequences of that scrub by performing a high-pressure distilled water purge over a thick towel, trapping the ejected debris safely away from your wardrobe.
And finally, you respect the physics of stubborn fused residue by utilizing extreme thermal shock, heating it to a pliable state, freezing it instantly on ice to break the adhesive bond, and safely removing it with a dull plastic edge.
The ultimate payoff, according to the source text, is absolute reliability. By following these precise steps, you guarantee that the appliance remains prepped in like-new condition, completely eliminating the risk of a messy ironing mishap right before that big meeting.
Knowledge, when applied systematically to the physical realities of our tools, yields perfectly consistent results. It gets it ready for your next ironing session without any stress.
It completely reframes how you look at the mundane tools sitting in your utility closet. Thank you for joining us on this deep dive today. We unpacked a surprising amount of geology, chemistry, and thermodynamics hidden inside a routine maintenance guide.
It is a fun one.
But as we wrap up, I want to leave you with one final thought to mull over or explore on your own. We just spent all this time uncovering the fact that a simple, handheld clothes iron requires an intricate dance of acidic flushes, alkaline scrubs, and 10-minute ice baths simply to clear out the hidden mineral rocks constantly building up inside its plumbing.
Yeah.
So considering the water running through your house every single day, what massive invisible sediments and stalactites might be quietly growing inside the other water-using appliances in your home right now?